Now we're going to take a little more detailed look at potential energy and do it by means of its formal mathematical definition. Delta U equals negative the work done by the restoring force. And for us, we have two restoring forces, gravity and spring. So the general definition, the concept, is based on the change in potential energy, not individual potential energy values, because as we said, it's only the change in potential energy that has physical meaning. This definition also shows us how potential energy is going to be used to talk about the transfer and the conversion of that potential energy into kinetic energy by letting it equal, by definition, negative the work done by the spring, and we are going to see what that means. Now, get this into your notes because this is important. It's an equality by definition, and the negative is put into the definition intentionally. It's contrived, this definition, to make the change in potential energy positive when the object is pulled upward and gravity is acting downward. So, for example, we lift an object, right? The minimum amount of force we will use to lift the object would be mg, right? We would have to be a smidge above, but that's our mg. Well, gravity doesn't shut off when we lift the object. And when we calculate the change in potential energy due to gravity, we don't focus on our force lift. We focus on what is gravity doing as we lift. And gravity is pulling down. We are lifting up, so the work done by gravity is going to be F dot delta y. The cosine of 180 is there because we're delta y in our force due to gravity in our opposite direction. So we get negative mg delta y, y final minus y initial. Here our y final is going to be up to some height h. Our y initial was position 0. And because of that darn negative that we threw in that is so important to make our potential energy concept work, we have to be a little careful with our negatives in our derivation. It's a good thing that you won't have to memorize this derivation. It's just helpful to understand how potential energy equations are giving us that conversion to kinetic energy. But back to that pesky negative, right? The delta U is negative the work done by gravity. So that negative is one negative. Our F dot delta Y gave us our second negative. The two negatives make a positive. So indeed, the change in potential energy is positive when we went upwards, right? Here we went delta Y up. When we went final minus initial, our change in potential energy was positive. So basically what we are doing then is simply picking off one of these mg y's, and we're letting that equal, by definition, our potential energy function. So it's kind of cool. Ultimately, it's kind of cool because it works, and don't let the fact that it's contrived to work make you think that the whole thing is contrived. It's not. It's consistent. It's mathematically consistent. It's consistent with what we observe in nature. So we're now going to be able to start talking about conversions to kinetic energy. But first, a nice little short page of notes here. Get these annotations down, and we'll talk more about conversion into kinetic energy.